The AI agent you're building is already becoming obsolete. In a world where models upgrade every few months, most systems are too brittle to survive. We're falling into the brittle agent trap, building rigid integrations for a technology that moves at light speed. Stop treating your AI servers like pets. Start designing for the future. Today, we're borrowing a 50-year-old secret from operating system design to solve a new world problem. I'm going to show you how to decouple the brain from the hands. This is how we build intelligence that actually lasts. Whether you're an engineer or a researcher, this is the key. Let's dive in.
So, here's a fascinating question. What happens when the very system you build to help an AI actually starts getting in the way as that AI gets smarter? It's a real problem, and Anthropic, the team behind the AI model Claude, just shared a really clever piece of engineering that tackles it head-on. Let's break down their solution, decoupling the brain from the hands.
I mean, this is the core challenge right here. AI models are evolving at a breakneck speed. Now that's awesome, but it creates a massive headache for engineers. Any system you build around a model today could be totally holding it back tomorrow.
And this leads to what they call the brittle agent problem. You build this whole system, this harness, to guide and control the AI. But when the AI gets an upgrade and becomes way more capable, that harness you so carefully built, well, it can suddenly break or just become a useless constraint. And they give this perfect real-world example. The engineers built a really clever fix for a model that had, and I love this phrase, context anxiety. Basically, it would get nervous and wrap up tasks too early. But then they ran that same system with a newer, smarter model, and guess what? The anxiety was gone. The model was more confident. So that clever fix was now just dead weight, slowing everything down. This kind of thing happens constantly. So how did Anthropic's engineers first try to solve this? Well, their initial approach was pretty intuitive, but it led them straight into a classic trap in software infrastructure, one they explain with a really powerful analogy.
At first, they just bundled everything together. You've got the AI's logic, its tools for actually doing things, and the entire record of the conversation, all packed into one single, neat little box. Seems simple, right? Efficient? Well, it turns out it had some really serious hidden costs.
And this brings us to one of the most famous analogies in tech, pets versus cattle. Think about it. A pet server is special. You give it a name, you take care of it, and if it gets sick, you have to nurse it back to health. Cattle servers, on the other hand, are totally interchangeable. If one fails, you don't fix it, you just replace it with another identical one. That all-in-one design, it turned every single AI session into a fragile, high-maintenance pet. And having these pets running around created huge problems. For one, they were super fragile. If that one container crashed, the whole session was just gone. Poof. Debugging was a total nightmare, forcing engineers to actually enter containers with sensitive user data, which is a massive operational risk. And maybe worst of all, the security was a disaster. The system's credentials were in the exact same place as code being written on the fly by the AI, code that could potentially be manipulated.
So it was clear this approach wasn't going to scale. And here's the breakthrough moment. They realized this super modern, cutting-edge AI problem wasn't entirely new. The solution was actually hiding in plain sight, in principles from decades of computer science.
I mean, seriously, where do you even start looking for an answer to a problem like this? You have AI models that are evolving in a matter of months, completely breaking the systems you just finished building. There's no instruction manual for that.
The answer, amazingly, wasn't in some futuristic new idea. It was in the past. They looked back to the foundational designs of operating systems.
And this quote just nails the core idea. Early OS designers had to solve this exact same problem. How do you build a stable platform for software that hasn't even been invented yet? They did it by creating these stable abstractions, things like files and processes, that hide all the messy complexity of the hardware underneath. So this insight led to a complete redesign. The new architecture is all about this idea of decoupling. Basically, separating the different parts of the AI agent, just like an OS separates your software from the physical computer chips. And here's what the new setup looks like, broken into 3 totally separate parts. First, you have the brain. That's the AI model itself and its logic. It's the decision maker. Second, you have the hands. This is an isolated sandbox with tools where the AI actually takes action. And finally, and this is critical, you have the session, a separate, permanent, unchangeable log of everything that happens.
So what does decoupling really mean here? It means each one of these parts can fail all on its own without taking the whole system down with it. If the hands crash, the brain can just spin up a new pair. It turns both the brain and the hands into disposable cattle, not those precious pets we talked about.
And hey, remember that massive security hole? This new structure just fixes it by design. The credentials, the keys to the kingdom, are now stored away in a secure vault, completely unreachable from the hand sandbox where the AI's code is running. So a prompt injection can't trick the model into just reading its own environment and leaking secrets anymore.
Okay, so this new architecture sounds great on paper, but did it actually work? Well, the answer is a huge, resounding yes, and it came with a massive performance payoff.
To measure their success, they focused on one key metric: time to first token. This is basically the delay you feel right after you hit enter. It's the time it takes for the AI to start generating its response. It's the lag that we all hate.
And the results were just incredible. A 60% drop in the median time to get a response. That's because the brain can start thinking immediately, without having to sit around and wait for the hands container to get all set up from scratch. But look at this. This is even crazier. For the worst-case scenarios, those really long wait times that make you want to give up, they saw a staggering 90% reduction. This change didn't just tweak the system, it fundamentally transformed how responsive and reliable it felt to the user.
So here's the bottom line. They built a system that is incredibly flexible and essentially future-proof. They can scale up countless brains whenever they need to, and any of those brains can connect to any set of hands, whether it's a code sandbox, a specific tool, or, as they cheekily mention in their article, even a Pokemon emulator. The system is ready for models and tools that haven't even been invented yet.
And that really leaves us with a fascinating final thought. This principle of decoupling, of separating the thinking from the doing, it isn't just about AI. It's such a powerful idea for building resilient, adaptable systems in any field that's changing at lightning speed. It really makes you wonder, what other complex systems in our world could benefit from a clean separation of the brain from the hands?